there are between 10 to 20 bits in a container. Amber wants to put the bits in packets. So if she puts 3 in each packet, there will be 2 bits left. If she puts 4 in each packet, there will be 1 bit left. How many bits are there in the container? So this question, our goal is to find out what is the actual number of bits at the beginning, okay, before she packed them into packets. So they presented us with 2 scenarios. First scenario is that if she put 3 in every packet, and she realized that she will have 2 bits left over. Second scenario is when she put 4 in every packet, there's 1 bit left over. Okay, so in these 2 scenarios, we should first think about what stays the same in both scenarios, which is in this case the number of bits. Alright, the total number of bits should be the same. Okay, now the condition here is there are between 10 to 20 bits in a container. So for this question, how are we going to approach it? We can use the listing method. Okay, so the listing method in a way it means the multiples listing method. So we shall see how to do that. Now another point I want to bring up is that the number of packets. Okay, so the number of packets in these 2 scenarios, do they have to be the same? Okay, and the answer is no, they do not have to be the same. The question did not say that the number of packets must be the same for both scenarios. Okay, so your first scenario, you can have, for example, say 10 packets. Second scenario, if it's not 10 packets, it's something else, 8, 9 packets, whatsoever, it's fine. Okay, the only thing that must be the same is the number of bits. So this is consistent between both scenarios. So let's go on to do the listing. Okay, so for 10 to 20 bits, okay, so they already give you a condition between 10 to 20 bits. That means what Amber should have for the number of bits should be from 11 to 19. Okay, so now first scenario, let's list down for the first scenario first. Now, how do I list it down? I'll list it down in a table form, so it look like this. Okay, so we just need to draw 2 lines. Now, if I put 3 bits in every packet, okay, that means 3 in one packet, 3 in another packet. Okay, so as we can see, that means in first scenario, 3 in one packet, 3 in another packet. This goes on and on. Okay, so I'm actually trying to find out what's the total number of bits across all the packets. So I hope you can tell this is actually listing out multiples of 3. Okay, so times 3 just means multiples of 3. Now, but remember, every time she put 3 in each packet, okay, whatever we know is that when she tried to put 3 in a certain number of packets, there will be 2 bits left over. Okay, so 3 multiplied by don't know how many packets, okay, 3 times the number of packets, those are the number of bits packed in the packets. But that is not all. Because with the 2 bits left over, you have to plus 2 to find out what is the actual number of bits was there really. Okay, like the real number of bits that's happening here. Right? So we're going to list out multiples of 3. So if you, now when you start listing out multiples of 3, take note of the condition given, okay? The question already say 11 to 19 bits, which means that you do not have to start from 3. Alright, now in fact, I'm going to start from 3, 6. So 3 and 6 no need because 3 and 6 is out of this range. Now I can start from 9. Okay, so the reason why I can start from 9 is because when later I plus 2, when I plus 2, 9 plus 2 here, right? 11, 9 plus 2 is 11. 11 falls within this range. Okay, so you can start from 9. Let's go on to list down 9, 12, 15. Now, how do you know where to stop? Okay, you can just list down a few first. Okay, because otherwise it will never be any. Just list down a few. Later we will see, you know, is there anything in common. And you're going to plus 2 to every of these numbers. So make sure when you list them, use commas to separate your numbers. Make sure it's well spaced so that it doesn't end up too cramped. Okay, and make sure all the numbers that you plus 2 is directly underneath the one on top. Alright, so this is what I just explained. So we can use 9 because when we add remainder of 2 to 9, your number of bits becomes 11, which falls within this range, okay? I'll move on, 12 plus 2, 15 plus 2, 18 plus 2. Okay, so we can stop here first. So one of these numbers, okay, the numbers at the bottom row indicates the number of bits in the container. Okay, now, but because we gotta depend on second scenario as well. We cannot just determine from the first scenario. So in my second scenario, this is where I go on to do the 4 in each packet. Okay, so another table needed. 4 in each packet means multiples of 4. Number of bits will be in terms of multiples of 4 across all the packets. Now, but I pack them in a certain fixed number of packets. Again, I do not know how many packets are there. It's okay. So 4 bits multiplied by the number of packets equals to the total bits in all the packets. But that is not all, because after I pack, I realized that I have 1 bit left over. So if I have 1 bit left over, my real number of bits in the container at first should include that 1 bit also. That's why I plus 1. Okay, so let's list down multiples of 4. Again, you don't have to start from 4, 8. You don't have to do that. You can jump to 12. Okay, if you jump to 12, it falls within this range. All right. Yeah, so if you jump to 12, you can start off with 12, then go on to 16, 20. Just list down a few again. You don't have to list down so many. All right. Okay, if later not enough, then you just continue. Okay, if you realize that there's no common number later. Okay, later you understand what I mean by common number. So let's plus 1, 16 plus 1, 20 plus 1. Okay, so 21 is outside of this range really. Okay, so you can just ignore that. Right. Actually, if you don't cross this out, it's fine also. Okay, you can just leave it alone. It's okay. Now, our total number of bits, remember we're talking about from the bottom row. Okay, let me just use my pen to highlight it out. So whatever I have in the bottom row here and in the bottom row here should match each other. I should find a common number between those two rows that I put in purple color. Why? Because in each scenario, the bottom row represents the real number of bits that could potentially be the real number of bits in the container. And it has to be the same number of bits in both scenarios, right? Okay, so as we can see, you should observe that 17. There are 17 bits in the container. And the question asks for how many bits? So that would be my answer.